Welcome to Lab 1 on charged tape. The purpose of this lab was to understand how charge can move between objects to create repelling and attractive forces. The objective of this lab is to calculate the amount of excess charge on a piece of tape after it has been charged. We would also like to find out how much the tapes have to be charged in order for one tape to float on top of the other in the setup which will be explained later on in this PowerPoint. From the completion of this lab, the charge of the tape was found to be 1.43 times 10 to the negative 9 coulombs, and the number of electrons lost from the tape was found to be 8.9 times 10 to the 9th electrons. Here is some background on the fundamental principles that was used during this lab. We used three different important equations throughout this lab. First, we used the universal law of gravitation to calculate the force due to gravity on the floating piece of tape. Second, we use the Coulomb's law to calculate the excess electric charge on the floating piece of tape. Using the charge calculated in Coulomb's law, we calculated the electric field produced by a charged tape. This calculation was later used to calculate the force on the floating tape due to the charged tape's electric field. Here is the observed model that we used displayed to the right. First, we charged both tape A and B and propped tape B using two different expo markers. Then, we brought tape A near tape B, which caused it to repel by a little bit. Using this setup, we would like to calculate three different things: the number of electrons lost after charging the tapes, the excess charge of the tapes, and the force on tape B exerted by tape A's electric field to keep it afloat. This will be done using the computational model. In this model, we define the system to be tape B and the surroundings to be everything else including tape A. First, we calculated the gravitational force, which is mg, which gave us 2.94 times 10 to the negative 3 newtons. Then we calculated the electric force. However, since tape B is floating and stationary, the electric force should be opposite in direction and equal in magnitude. So the force of electricity is actually the same in magnitude as the gravitational force, just in the opposite direction. Then we calculated the excess charge on the tape using Fe and the Coulomb's law, and we got 1.43 times 10 to the negative 9 coulombs by solving for Q. Then we could calculate the number of electrons lost by the tape by dividing the previous number by the charge of one electron. This gave us 8.9 times 10 to the 9th electrons lost. Here is the computational model. As you can see, the code is to the left. First, I defined the constants. Then I defined both of the tapes as spheres. Then I made calculations for the gravity of force gravity and the force caused by electricity. After that, I calculated the E field caused by A, and using that E field, calculated the force on B caused by the E field produced by A. As you can see, the charge that was calculated successfully allowed the tape B to flow above tape A. Tape B is blue, tape A is red, and as you can see, tape B is floating on top of tape A without touching it. One thing that could have caused errors in our final result was our assumption that air resistance is negligible. Because there was air resistance acting downwards on the tape along with gravity, the charge of the tape must have been greater than what we've calculated using the observed and computational model. This is because there's more downward force acting on the tape, which means that there must have been more electric force on the tape in order to keep it afloat. Another assumption that we could have led to skewed results is our representation of the tape as point charges in our calculation. In reality, these charges are distributed in random ways which cannot be modeled simply by a point charge. Finally, errors could have resulted from us handling the tape too much. Here are the discussion questions for this lab. What if electrons had a positive charge and protons had a negative charge? The observations that we made would not change. Instead of the tapes being positively charged, the tapes would be negatively charged. The tapes would still be repelling because likes always repel. However, to get an attraction, we would need to charge an external object like a pen with a positive charge. Second, why is it important to handle the charged tape as little as possible? It is important to handle the tapes as little as possible because the tape begins to neutralize as you touch it. It tries to regain the electrons that it had lost after peeling the tapes from each other. In conclusion, we found that it would require 1.43 times 10 to the negative 9 coulombs of charge on either tape for tape B to flow above tape A. Thank you.